Welcome to our next lecture in Math 1342, Elementary Statistics at Dallas College with Professor Bailey using McGraw-Hill ALEKS. Today we're looking at sections 7.3 and 7.4 about constructing confidence intervals for a population proportion, finding the sample size, and looking at how we can construct confidence intervals for small samples. And in my in-person classes, I do a project each semester, and that's what this is related to. This section is very important to your project because this is exactly what the project is about, specifically looking at population proportions of college students who hold a specific attitude. So if you're in my lecture class and you're watching this, pay close attention to this because you're going to need it on your final presentation. So let's look at an example. The National Association of Music Merchants surveyed 800 parents of children 5 through 18, and 632 of them said that music education has a positive effect on academic performance. Assuming these parents to be a random sample, we would like to construct a confidence interval for the proportion of parents who believe that music education has a positive effect on academic performance. We're going to use the following notation. A lowercase p is the population proportion of individuals who are in a specified category. This is what the category is based upon your hypothesis, right? Like maybe I want to know how people's attitudes about anything, about voting, about shopping, etc. And so that proportion of the population that agree with that, whatever your hypothesis is kind of that proportion. X is the number of individuals in the sample who are in this specific category. N is the sample size. P hat is the sample proportion of individuals who are in the specified category. And remember, P hat is just defined, it's the sample proportion, so it's just the number of people that select that category over the total sample population. Again, very logical. So in order to construct a confidence interval, we first need a point estimate. The point estimate for the population proportion, lowercase p, is p hat, which is our proportion from our sample. We're going to calculate a proportion from our sample, and then we can use that as an estimate for the population proportion given some circumstances. We also need the standard error of p hat, and by the central limit theorem for proportions, we have that this equals the square root of p hat times 1 minus p hat over n. Finally, to compute the margin of error, we multiply the standard error by the critical value. And in this case, we're using the z alpha over 2. This is the area in the tails, remember. So we take z alpha over 2 times the standard error. And then finally we have our confidence interval, which is our point estimate plus or minus the margin of error. And we've seen this before in other calculations. The method for constructing a confidence interval for a population proportion requires that the sampling distribution be approximately normal. The following assumptions ensure this, and that, of course, we always have a simple random sample. Anytime a sample is not done randomly, it draws into question whether the data that's found from that can actually be used to make judgments or inferences or statements about the population as a whole. The population is at least 20 times as large as the sample, so that the sampled items are independent. And the items in the population are divided into two categories. We'll get more into this in a minute. The following thing is that the sample must contain at least 10 individuals in each category. So again, let's look at an example. In a survey of 800 parents, 632 said that the music education has a positive um, effect on academic performance. We want to construct a 95% confidence interval for the proportion of parents who believe that music education has a positive effect. So the first thing we have to do is to check our assumptions. We have a simple random sample. We saw that before. We are surveying 800 parents. It's probably pretty reasonable to assume that there are more than 800 parents in the population. Times 20, that would only be 16,000, so I think we're safe there. And we can divide the population into two categories, those who believe that music has a positive effect and those who do not. There are 632 parents who said that they believe it has a positive effect. That means there's 168 who do not. So there are at least 10 or more items in each of the categories. So we have met all of the assumptions. Okay. The next thing we're going to do is to find the point estimate. This is the number in the sample over the sample size. The number in the sample who hold that characteristic, in this case, which is believe that music education has a positive effect. So 632 out of 800 said that this was true. From that, we're going to find the margin of error. Remember, this the radical is the standard error. And then we'll find the confidence interval, which is the p-hat plus or minus that margin of error. Okay. And finally, we will do that confidence interval. Okay. So here we have the calculations that are quite straightforward. 632 over 800 equals 0.79. We use that p-hat, 0.79 times 1 minus 0.79 over n, which is 800, and then times it by our z alpha over 2. Now, where did this come from? Now, there's two ways you can find this. You can use table 3, and at the bottom of table 3, you see the z score for confidence levels. The other way you can do this is recognizing that a 95% confidence interval, this means that 95% of the data is in the middle of the table. That means we have two tails that make up the other 5%. We can, so if both tails make up 5%, each tail makes up 2.5% or 0.025. So if you're looking in that, if you're looking in table 2, what you're looking for in the right tail is 0.025, which is the area. But remember, the A2 table gives the area to the left. So if 2.5% is in the area to the right, then we'd have 97.5 or 0.975 area to the left of that. And if you look in the A2, you will also find the score there that at 1.96, the value in the table is 0.9750, which remember is the area to the left. So you can use table A3, which I think is probably the easiest, looking at the bottom row, because most of the confidence levels are there. So our critical value is 1.96. Again, you can use these tables on the test. There's a copy of them. Do not write on those tables, but you can find a copy in eCampus. And then finally, we have our margin of error, 0.028225. So we simply add it or subtract it, and we get this range, 0.762 to 0.818. And then the final thing that we do is that we make a statement about this using our confidence level. And this is exactly how we would state this. We are 95% confident that the proportion of parents who believe that music education has a positive effect is between 0.762 and 0.818. Okay. In the back of section 7.3, there is ways that you can use your calculator. Also, Excel. These are great. These are the exact same examples we are doing right here that are in the book. This is what I was talking about, table A3. So I highly recommend you these. You have Excel homework every week. And the examples in the book match the examples in my lecture and in the class that we're doing. You've already got those examples, you know how to calculate them manually, so it's not a bad idea to figure out how to calculate them um, using the technology. So here we have another example. So we have a simple random sample. The children were tested. 200 third graders, that's our sample size. 142 of them showed improvement. So that would mean 58 did not show improvement, and we want to construct a 95% interval, and then we want to see if it's reasonable to conclude that more than 60%. Okay, you're going to do this the same way we did the last one. Find your p-hat value, your point estimate, find your margin of error, and then find your confidence level, p-hat plus or minus that margin of error. I'm not going to go through this, but I do have the answers here, so I suggest you hit pause and try this one. Again, here are all the formulas that we were going to use to go through it. You should get a 95% confidence level, that is 0.647 to 0.773. So we are 95% confident that the proportion of children who would benefit from this reading program in the population is between 0.647 and 0.773. So you can basically think between 65 and 77%. So because we are 95% confident that it's between 65 and 77, then 60%, is it reasonable to conclude that more than 60% of the students would improve? And that is yes, because we are 95% confident that all of the values are above 60%. A smaller margin of error makes the confidence interval more useful. If we wish to make the margin of error of a confidence interval smaller while keeping the confidence level the same, we can do this by making the sample size larger. So remember, here's our formula for the margin of error. This is our critical value times our standard error, which is using the point estimate and the sample size. If we rewrite this formula and solve for the sample size, we get this value here. This is the minimum sample size needed to obtain a margin of error of size m. If the value of n is not a whole number, round up to the nearest whole number. So what this means is we can select a margin of error that we want to use and then figure out how big the sample size is needed to attain that. In order to use this formula, we need a value for both the margin of error and for the point estimate. We can set the value of the margin of error, but we don't know ahead of time what our point estimate is going to be. And so there's two ways that we determine a value for a point estimate. The first one is we use a value that is available from a previously drawn sample. This is the most common when we look at another survey, another study done specifically that's connected to our own hypothesis. So we look for a prior study. The other way is just to assume that p-hat is 0.5, which makes the margin of error as large as possible for any sample size. If we do this, notice 0.5 times 1 minus 0.5 is 0.5 squared, which is just 0.25. So they've just plugged in this value of 0.5 to get this simplified formula, but it's better for you to memorize this one And then just know if you don't have a prior sample, we're going to use p hat equals 0.5 or 50%. In a previous example, in a sample of 800 parents, 632 believe that music education has a positive effect on academic performance. Estimate the sample size needed so that 95% confidence interval will have a margin of error of 0.025. I've given you the formula here. So really what we're going to do is we're going to plug and play this into our formula. We find the critical value. This is our Z alpha over 2 of 1.96. We already talked about finding that. We find our p hat, which is 6 from our sample, the number that believe music education has a positive effect over the sample size. We saw that before. The desired margin of error, this was given to us because we're trying to find the sample size to create a margin of error that's 0.025. And so the necessary sample size, plugging all those values, is 1019.71. Since we're talking about a sample size, we're talking about a survey, etc., larger is always better. And so we want to always round this number up, and it has to be an individual number because we're looking for how many items, people, etc., that we're going to sample, and we can't sample a portion of an item, so we can't use a decimal. So we're going to round this to 1020. We always round up, even if that next digit is below 5. We always round up because the larger sample size is always going to perform better to make inferences on the population. Okay, so we've got a 95% confidence interval for a proportion who believe that physical education has a positive effect on academic performance. And in this case, we have no value for the point estimate, p hat. Again, we have the other values needed. So remember, when we don't have a value for p hat, what do we use? Again, hit pause, try this, and then come back. So when we don't have a value of p hat, we're going to use 0.5. We have the critical value. Again, 0.5 times 1 minus 0.5 is 0.5 squared, or 0.25. We plug in the Z alpha over 2. We plug in our margin of error and calculate this value, and we get 1,536.64. Again, we're always going to round up, so we're going to round this up to 1,537. So we need at least 1,537 individuals in our sample to ensure that we keep this margin of error low. There's a couple of practice problems here. Again, I'm not going to go through these, but these are great problems to try again. I've got the answers here. Hit pause. You can also go into your text and find these, but I'm not going to walk through these problems. I just include them here so you get extra practice, and I highly recommend that you do these here. The more you practice, it's like drilling in a sport, the better you'll do. And so these are the values for the sample size for A and the sample size for B. So we have the method that we already used for constructing a confidence interval for a proportion. This requires that we have at least 10 individuals in each category. When this condition is not met, we can still construct a confidence interval by adjusting the sample proportion a little bit. We increase the number of individuals in each category by 2 so that the sample size increases by 4. Sample proportion p hat changes to the adjusted sample proportion. So this is the adjusted sample proportion. I'm kind of calling it p bar. And again, notice that we add 2 to each of the categories. Since we're adding 2 to x, the number that have the agreement, we're also going to add it to the not x, so to speak. And so that means we're increasing the whole sample size by 4. When using this small sample method, the standard error and critical value are calculated in the same way as in the traditional method, except that we use the adjusted sample proportion, p bar. I don't know that p bar is a real term. I don't know if I made that up or not, but it's the sample proportion with the little, got the smaller sombrero over its head, if you will. And E plus 4 we use in place of the sample size n. So in this case, the standard error becomes that p bar A times 1 minus p bar A over n plus 4. So here, let's try a problem. I've got the formulas here. In a random sample of 10 businesses in a city, 6 of them had more than 15 employees. So that means 6 of them had more and 4 had less. And so you can see that in neither of these categories do we have at least 10 responses. So we're going to use the small sample method to construct a 95% interval for the proportion of businesses in the city that have more than 15 employees. So we need to calculate our point estimate. This is our adjusted point estimate. These are the ones that have more. 6 had more, so we're going to have 6 plus 2 over 10 plus 4 for our adjusted sample proportion. That gives us 0.5714. For a 95% confidence interval, we're still at that critical value, or Z alpha over 2, 1.96. And so we just plug in the values and we get that the population proportion, we're 95% confident that the population proportion is between 0.312 . The small sample method can actually be used for any sample size, and some recent research has shown that it has 2 advantages over the traditional method. The margin of error is smaller because we divide by n plus 4 rather than n, so we're making the denominator larger, which makes any number, when you increase the denominator of a fraction, you're decreasing the value of the number. Think about it like if you have 1/2 versus 1/4. 1/4, the larger denominator, is a smaller number. Larger denominator, smaller overall number. The actual probability that the small sample confidence interval covers the true portion is almost always at least as great as or greater than that of the traditional method. So we're getting the same thing, if not a better estimate, using the small sample. Again, I have another problem here. I'm not going to walk through this step by step. Use the small method sample to construct a 95% confidence interval. And if you do this, I've included the formulas here so you know how to do it. And this is the interval you should get, 0.302 to 0.751. Again, these are the things that you need to know from 7.3, how to construct and interpret confidence intervals, how to find the sample size necessary to obtain a given confidence interval. And again, this is in 2 ways: when an estimate of p hat exists and when no estimate exists. And then again, how to construct confidence intervals for a population with small sample size. The last thing we're going to look at is section 7.4, which is determining which constructing a confidence interval. One of the challenges in constructing a confidence interval is to determine which method to use. The first step is to determine which type of parameter we are estimating. Are we looking for a population mean, or are we looking for a population proportion? If you're estimating the population mean, there are 2 methods for constructing an interval: the Z method and the T method. This refers to table A2 and A3. Okay? To determine which method to use, we must determine whether the population standard deviation is known and whether the population is approximately normal and whether the sample size is large, specifically if the sample size is more than 30. Here's a great table to walk through this. So the first thing we're asking ourselves is, do we know the standard deviation of the population? If we do, then notice we're going to ultimately, this is the trigger between the Z method and the T method. If we don't know the standard deviation, then we use the student's T-score. Okay. As soon as we do that, then we question, let's assume we know it. Do we have a large sample size? Yes, we just go into the z-method calculation. If we don't have a large sample size, then we ask, do we know if the population is approximately normal? If it is, then we can use the z-method, and if not, we're kind of stuck. And so this says consult a statistician, which I think is kind of funny that the book says that. So we have to try something else if this isn't the case. It's very similar. If we don't know the standard deviation, we have a large sample size, we use the t-method. If not, we ask if the population is approximately normal. If it is, then we use the t-method, and if not, then we have a problem and have to figure out something different. Again, this is the chart for population means. Population means, okay? Either z-method or t-method deviation. Decide which type of parameter. Simple random sample of 200 electrical circuits taken from a large shipment. 14 were defective. 95% confidence interval for the proportion of circuits that are defective. So we've got the table here, but notice what we're looking for. Remember the table. Actually hit pause, see if you can figure this out, and then hit play again. We're going to go through a number of different examples. The first thing figure out what we're looking for, and we're looking for the proportion of circuits that are defective. This table is all about means or average, so it doesn't even come into play. The proportion is 0.35 and 0.105. Here we would find the point estimate and then the point estimate plus or minus the margin of error. The table is not even involved. Okay. Okay, now we have the population mean. We do know the standard deviation, so we're up here. So we know that it's the sample size. The sample size is 80, so we're going to use the z-method here. Okay. Again, pause and try this one. In a sample of 100 children, 22 had reading skills. That means 78 did not. So we have more than 10. 99% confidence interval, proportion of children. Again, the table does not have anything to do with this. This is about proportions. So we're going to look for the proportion estimate. The point estimate, and then the point estimate plus or minus the margin of error. All right, here we're looking at a mean. We do not have the population standard distribution, so now we're at a no. Is the sample size larger than 30? This is no. Our sample size is 25. Is the population approximately normal? Yes. And so we're going to use the t-method for doing this, discussed earlier in the chapters. And so that walked through all the different types of examples that you might have.